here we are at lesson 6C. So today students will be able to simplify expressions using the greatest common factor and checking with the distributive property. Students will also be able to explain distributive problems correctly, and this is important for factoring polynomials in later math classes. So today we're using distributive property and factoring. Factoring is the opposite of distributing. Okay, so factoring is breaking it down, breaking it back down, breaking it down to factors. And so today we're going to be doing the opposite of distributive property, but remember what distributive property was. It was multiplying something in because we have 5 groups of this, or 5 copies of this whole group. And so if I have 5 copies of x, that means I have 5x. If I have 5 copies of a plus 3, that means I have a plus 15. Remember here, if we have 6 copies of y, I would write that as 6y. 6 copies of a plus 7 would mean I would have plus 42. Down here, if I have 3 copies of m, I would write 3m. If I have 3 copies of a minus 8, I would have a minus 24. And so that was distributive property. Remember, we're multiplying it in. So this is multiplying, write this down please, multiplying a factor into the group. This is multiplying a factor into the group. We're multiplying it in. And so distributive property we're multiplying in. Factoring means we're dividing it out. So we're going to use the greatest common factor. Remember, that's the largest number that divides evenly into other numbers. So for example, if we have 15 and 12, the greatest common factor between 15 and 12, well, let's think. I know 1 obviously goes into both of these, but we want a bigger number. The bigger number would be 3. Is there any more? No, so the GCF here would be 3. Out of 30 and 42, oh, and by the way, that means I could have 3 times 5 to get to 15, and I would have 3 times 4 would be to get to 12. And so this greatest common factor would be 3. All right, let's look at 30 and 42. I know 2. But there's got to be something more. So let's think 3. I know 3 would go into this 10 times. 3 would go into this one, into this one. How many times would 3 go in? Let's see, 14 times. So we could probably get some more out of this. What about 6? I could take 6 out of this. So let's write that one down. 6 times 5 would be 30. 6 times, what would that one be? 6 times 7 would be 42. So it looks like 6 might be our biggest number there, because we can't take anything out of 5 and 7. What about here? 14 and 21. Hopefully you can see this one would be 7. Okay, because it's 7 times 2 would give us 21. 7 times 2 would get us 14. 7 times 3 would be the one to get us 21. All right, let's think of these. I see 2. I see 4 would work. Let's think of more. Ooh, what about 8? I think 8 might be the biggest one. Nope, not 8. Maybe more than that, maybe 12. Let's try 12, thinking of the biggest number we could possibly take out. I could get 12 times 2 to be 24 and 12 times 3 to be 36. Is there anything else I could take out of 2 and 3? Nope. Okay, so let's try one. What would it look like if you didn't know the common factor, the greatest common factor? Because here it's kind of easier to see. So let's look at 50 and 15. 50 and 15, I know I can divide out 5. So let's see if there's anything else we can divide out of there. So that would be 5 times 10 to get us to 50. 5 times 3 would give us to 15. And oh, it doesn't look like there's anything else because I'm checking with these last 2 factors. So breaking it down to factors means you're breaking it down to what was multiplied to get to the number. So the factors, for example, of 32, factors would be 8 and 4. Of 48, it'd be 4 and 12. Of 16, it'd be 2 and 8. Of 120, it'd be 3 and 40. Of 54, it'd be 6 and 9. Sorry, 9 and 6. Of 132, it'd be 12 and 11. And so these are the factors. These are the multiples. Okay, so we want to look for breaking stuff down into factors. So we're looking for what divides evenly. So the biggest number that divides evenly. All right, so that means over here, factoring means breaking it back down to parts. Go ahead and write that down. We're going to work with the whole numbers first before we try the fractions. So let's look at 8 and 12 and see if we can think of the biggest number that we could take out of both of those. What do you think could have been multiplied in? Well, I know not 8, but let's think back down to 4. And I could take 4 out of both of those. And so I'll start with 4 here. And in the parentheses, we would still have some numbers left over. So if I take both of these and divide by 4, if I divide both of those by 4, then what I would have left was 2x and 3. And so I can take out a 4 and get 2x left over and divide out a 4 here and have 3 left over. So it's what it was before we distributed. All right, what about this one? Looking at 7 and 21, what number could I take out of both? Well, I could take out a 7. If I do take it out, I write a parenthesis with what's left. If I take 7 and divide this by, divide 7c by 7, I would only have 1c left over there. This looks like it was a minus problem, and if I divide out a 7 from 21, I would have 3 left over. So this is what it looked like before distributing. Let's keep trying that. What about 12 and 14? So 12 and 14, I'm going to think of 12s. I can't take 12 out of 14. Next number down would be 6. I can't take 6 out of that. Next number down would be 2. Could I take 2 out of both of these? Yeah. All right, so I'm going to start with a 2 outside. And let's think of what we would have here. So 12 divided by 2 would have given me 6, and that has the W on it. 14 divided by 2 means they must have added a 7 right there. And so that's what we would work back to. Next one down, let's look at 6 and 21. So I know I can't take 6 out of 21. Next one down for 6 would be 3. Could I take 3 out of 21? Yeah. So I'm just thinking of the smaller numbers factors and checking it with the bigger one. It's kind of like the opposite of making common denominators also. So if I take 3 out of 6y, I would have 2y left over. Looks like it was a minus. If I take 3 out of 21, I would have 7 left over. And so that's what it would have looked like. Let's try the next two, 27 and 15. 27 and 15. Well, I know 15 is divisible by 5, but 27 isn't. So the next one down would be a 3. Could I divide 27 by 3? Yeah. So let's take out a 3. All right, so that means if I divide out 3 from 27, I have 9, and that one has the H. This looks like it was a minus. And if I divide out 3 from 15, that means I would have 5 left over. And there it is. All right. Ooh, this one's good. These are both 32s. And so I could take out 32 from both of these. If I divide out 32 from this one, I would have 1D left over. Looks like it was a minus. If I divide out 32 from this one, I would have 1 again. And so that's what it would have looked like before distributing. Ew, this one has fractions. How do we handle fractions? Well, let's write a little note about that before we do this one. Make denominators the same, find GCF of the numerators. Okay, make the denominators the same, find the GCF of the numerators. So that means if I want this one to be over 2, then I would have 1/2 A minus, if I want that to be a 2, I'd have to multiply by 2 and by 2, and so that would be 4/2. All right, I made the denominators the same. Now I take out the fraction from the bottom. And so the fraction I'm going to take out here is a 1/2. And what would I have left if I do that? Well, if I take out the 1/2 from the first one, I would still have the A minus, and now I'm going to take out a 1/2 from this. And so what I'm going to be left with is a minus 2. No, I'm not. I'm going to be left with a minus 4. Oh my goodness, Mrs. Silva. All right, so 1/2. Taking out of the A, dividing this by 1/2 means I have A left over. And if I divide this one by 1/2, I would have a 4 left over. Or in other words, you're trying to backwards think. What could I distribute this in for to get to that? All right, let's try that again. On this one, I see the denominator's already the same, so I'm going to take out a 1/5. If I take out the 5th from both of these, what I would have left is 4Z minus 28, because that's what's up top. Now I can see I can take out a 4 from both of these, and so I'm going to take out some more. So anytime this happens, you can go ahead and add it to the top. So out of 4 and 28, I can still divide by 4 again, and so I'm going to add that to the top of what I'm taking out here. So I'm actually going to take out 4/5. And when I take out the 4 now from the z, I'd have z left over. If I divide out 4 from 28, I would have 7 left over. And so that would be the fully factored form. Let's try that again. Here's 1/5 b minus 1. So I'm going to make that into 1/5 b minus, well, I want it to be out of 5s over 5, so times 5 times 5. And so that's going to be minus 5/5. Now I can take out that fraction. I'm going to take it out as 1/5, and I'm going to write what was up top. 1b minus 5 is what that would look like afterwards. Now let's go back to this one that was down here, number 18. I see the denominators are already the same, so I know I'm going to take out a denominator of 10. And then I'm going to go ahead and look at those top numbers. Between 3 and 9, I know I can divide out a 3. So I'm going to put that one up top. What I would have left is just 1r plus, if I took out that 10, I would divide the rest of it by 3, and 9 divided by 3 would give me 3 right there. Okay, so that would be broken down into the factors. Fractions might take a little bit of practice. We'll practice some more of those in class when we're all done with the video today. Now over here to decimals. Decimals, we're going to make the inside a whole number. And so we want to see what we could multiply by for this one. So we want to make the inside a whole number. So for this one, if I multiply by, looks like it's 0.1, 1 decimal spot. So if I take out 0.1 from both of these, that means what I would have left is 9x plus 36. Well, now that I have a 9 and a 36, I see that I could take out a 9. And so what I'm going to do is when I take out more numbers, I multiply by what's already out there. And so I'm going to actually take out 0.9. And when I do that, this would actually become 1x plus, and 36 divided by 9 is 4. And so that would be fully worked down to its factors. Weird, right? Let's try this one. I'm going to start by seeing it's 1 decimal place. So I'm going to take out a 0.1. What that lets me do is move it once. So this is now going to be 16x minus 24. Now looking at 16 and 24, I know I can't divide out 16, but I could divide out 8 from both of these. So if I take out an extra 8, if I'm going to divide out an extra 8, that means what I'm really taking out is 0.8. Now, if we take 8 out of 16, so 16 divided by 8 is going to be 2 with the x. 24 divided by 8 is going to be 3. And so that would be our factored form. Let's try that one again. All right, again, I see 1 decimal place. So I'm going to start with 0.1. And then I'm going to write what this would be without decimals. 23x plus 46, because I moved them both once. Now looking at both 23 and 46, I see I could take out an extra 23. When I do that, this becomes 2.3. And now I think of dividing both of these by 23. So I would have 1x and 2 left over. So that's our factored form. Last one. Now this one, notice we need 1 decimal place here. But for the second term, the constant, I need 2 decimal places, which tells me I'm going to take out 0.01 from all of these. Now that means I'm going to move this twice. So I'm going to have 320x minus 128. Now that I've done that, I can look at these bigger factors. All right, so let's think of something we could take out of both 320 and 128. I'm thinking maybe a 16. 16 I know goes into 32. What about 128? Well, let's try maybe a smaller number then if we can't see that. Let's try a 4. Or a 4, yeah, let's try 4. So that would make this 0.04. And what we would have left is 80x minus 32. Well, I see I can still take out some more. 32 I know is divisible by 8. 80 I also know is divisible by 8, so let's take out another 8. All right, so I'm going to write it there just so I remember. 8 times 0.4 means this would be 0.32. And if I take out 8, that means I'd have 10x minus 4. Oh, we're almost there. Now I see I can take out another 2. So this is how you work it if you can't quite see the greatest common factor right away. All right, 2 times 0.32 is going to be 0.64. And if I divide out